Okay, in this one I'll try to get through as many problems as I can, maybe 3 more. Remember with the last lesson, we went through the first one, determine the convergence or divergence. This one, we'll try this, determine the convergence or divergence. And this time I want you to observe one thing. First, that this is equals, or this is where n equals 0 and starts at 0 instead of 1. So we're going to make the shift so that it will match the theorem properly. The other thing is to observe the condition where the limit of a sub n as n approaches 0, as n approaches infinity, must equal 0. And I believe that's easy for you to see here, realizing that there's an understood 1. 1 over this factorial is most definitely 0 as n approaches infinity. So now let's rewrite this summation as n goes from 1 to infinity. Let's take the negative 1. Now that had originally been to the n, so now we'll make it n minus 1, because that means n was supposed to, let's do it this way, n was supposed to have started at 0. N was supposed to have started at 0. So now, if I plug in a 1 here, 1 minus 1 is 0, so I'm rewriting it properly. And then we have what? 1 over, instead of 2n plus 2, if you have to add 2 to 0, is that how I want to say it? No, that's not, because of the coefficient of 2 here. Okay, so n was supposed to start out at 1, so now I'm going to need to do this. 2 times n minus 1, just like I did above, plus 2, all factorial, which equals, now think about it while I'm writing, because we don't want to write out more than we have to. So 2 times the quantity n minus 1 is going to be 2n minus 2, and then plus 2. So 2n factorial. So now this matches the form of the theorem, and this right here is n minus 1. Okay, so what we have to show, since the first condition was already met, is now we have to figure out if 1 over 2 times the quantity n plus 1, now this is for a different reason than we did the n minus 1, factorial is less than or equal to 1 over this, always. And if it is, then the series converges. Now it may be kind of intuitive to you that it is, but let's just do one more step. Let's distribute the 2 through. Is this fraction always less than this fraction? Well, if it is, then this denominator needs to always be bigger than this denominator. Well, of course, 2n plus 2 factorial has 2 extra factors, positive factors that you're multiplying by. 2n, just think about it, 2n plus 2 times 2n plus 1 times 2n factorial. So these two pieces of a product definitely make that denominator bigger than this one, so that is true. So the original series converges. Okay, let's think about this series. This is already starting out at n equals 1, so all that we have to do are check the two conditions, and right now let's look at the limit of this as n approaches infinity. What does that equal? I'm sure I gave you way more than enough time. The limit of that as n approaches infinity is 1. So the first condition's not met, so that series diverges. Okay, for this last example, I will say you can read the explanation that they give on page 620 because theirs is a little bit different than mine. The first thing that I want to do here is observe, what's going on. You want to try to write this as a series. So what are you doing? You're taking n starting out at 1, right? And first you're taking 2 over 1 minus 1 over 1. Then this is going up to 2. Then this is going up to 3. So my denominator is going to be my n, as it goes up and up and up and up. And then all my numerators are doing is switching back and forth between 2 and 1, between 2 and 1, between 2 and 1. So that leads us to write our series as 2 over n minus 1 over n. And then, again, you could see this would be plus 2 over 2 minus 1 over 2, plus 2 over 3 minus 1 over 3. So this series looks to be the correct way to write that. Okay, so now let's think about this. Let's simplify it. And these are like terms you can combine. Now, surely you recognize this. And again, I guess maybe I should have said, okay, this does meet the first condition, where your limit is n approaches infinity of an does equal 0. But what's more important is you should be able to recognize this as a special type of p-series. You've probably been screaming it the whole time I've been rambling. This is the harmonic series, so it does diverge.